In this example, we are going to approximate the area under the curve of cosine x over x using Simpson's rule. We're going to do 10 rectangles to approximate this, and we're going to do this over the interval from 1 to 3. So Simpson's rule says you want to find the approximate area by taking the width of each rectangle, dividing it by 3, and then multiplying it by a series of products and sums that you see here inside our brackets. So these x values are the endpoints for our rectangles, which we'll determine here in a moment. And so for the first value that you want to plug into your function, that goes here. You plug in your next x value into the function and multiply the value of the function times 4. And then you do the same thing, but you alternate 4 and 2. So the next x value you plug into your function and multiply by 2. Then the last value that you should have in here is your xn, which in our case would be x10. So we're doing 10 rectangles to find the width of our rectangles. I take 3 minus 1 to get the length of the entire interval and divide by 10 to find the width of each rectangle. So when I take 3 minus 1 and then divide that by 10, I get 0.2. So in front here of the brackets, we're going to have 0.2 divided by 3. And then inside the brackets is where we start plugging in values. Now, because we're starting at 1 and our width of each rectangle is 0.2, here are the values that we have. We have 1, and then if I add 0.2 to get to the edge of the next rectangle, it's 1.2, then 1.4, 1.6, etc. And then when we get to x10, that will give us our last endpoint, which is 3. So when I start plugging in these values here, once I get that sum, I multiply it by 0.2 divided by 3, and we'll get negative 0.22, which means there's more area under the curve below the x-axis than there is above. Now, let me show you how you can save yourself the arithmetic and worrying about rounding errors by using the calculator to do this. So you want to go into your y equals to define your function. So in y equals, I'm going to choose cosine x and then divided by x. So there's our function defined in y1. Now I can go back to the home screen and I can start entering these values. Take your time. This is kind of a lengthy arithmetic problem, so just take your time. So I'm going to start off with 0.2 divided by 3, and in parentheses, I'm going to put all of my function values. So my first function value would be f of 1. We defined it in y1, so I'm going to hit this alpha button, and then this button here, the trace, and it comes up, and I'm going to choose function 1, y1, and then I'm going to put in parentheses, I want to evaluate that at 1. Then I want to add that to 4 times the value of the function at 1.2. So I'm going to come up here, choose y1 again, and put in parentheses 1.2. Plus, then I'm going to do 2 times the value of the function, and now I'm going to do 1.4. Whoops, I forgot my parentheses here. If you forget something and you don't want to have to start over, you can go to where you want to insert something and then hit second delete, and it will leave a space for you to insert without copying over. All right, so after the value of the function at 1.4, I'm going to add 4 times the value of the function at 1.6. plus 2 times the value of the function at 1.8 plus 4 times the value of the function at 2. I'm just going to go ahead and continue to type all this in. So the next one's going to be 2.6. And 2.8. Now when we get to the last one, we're not multiplying anything by the value of the function. The last one is just going to be the value of the function at your last value of x, which in this case would be 3. Now I'm going to close off my big parentheses, in which has the 0.2 divided by 3 on the outside. And that gives me negative 0.21772884, which when rounded, you'll get negative 0.22.